Okay, we are doing the back side to this worksheet, except, oh, there's my stylus. All right, a woman interested in politics wants to know if she should run for office. She only wants to do so if there's a reasonable chance of winning the election. She plans to do a survey of registered voters to see how many people would support her candidacy. So what would the null hypothesis for this test be? H naught is pi is equal to 0.5, because that's the point at which, if we break that, she will win. So the alternative, HA, is going to be pi is greater than 0.5. All right, number 30. If a survey of 75 people is done and 53% said that they would support the candidate, is that enough evidence to say that she's probably going to win? So we need to run a simulation. So we are doing a sample of 75, and this can be 1,000. And in this one, we want to do proportion of heads, and we get a 0.53 as our sample statistic. What do you think? No. So that's kind of weird, right? If you went and talked to 75 people, and 53% of them said, yeah, we'll vote for you, and you'd be like, great. Is that evidence to suggest that you're going to win? No. 53 is so close to 50, we can't really say that you would get most of the votes. So how could we fix this? Talk to more people. Yep. If we talk to, say, 500, is that going to change things? So if we change this to 500, and then draw our samples and run our test, oh, that's still not enough. So in
You
this
should
case,
screen.
oh, sorry, Garrett. How about that? Now you can see it.
There we go.
Even that's not enough, right? Well, what if we talk to 1,000 people? And then we run 1,000 samples, that would do it. So one way to be sure is to talk to more people, or if you happen to talk to the same amount of people, but more of them supported you, that would be enough evidence. So let me turn my speakers up. Turn these back down. Okay. Now, some of these questions are going to be hard to answer. Oh no, this one is the one we want. If two surveys each found that 53% would support the candidate, which one would be more likely to reject the null hypothesis? A sample size of 100 or a sample size of 500? 500. The more people you talk to, the harder it is to have a high z-score. Does that make sense? So if I were to draw these two curves, 50% is in the middle of each of them, right? So this is my 100 people list, and this is my 500 people list. 50% is in the same place on both of them. The difference is the standard deviation, right? Which is bigger? This standard deviation or this standard deviation? Which one is going to have a bigger standard deviation? Well, let's think about it. So if I graph 53%, which one has a smaller p-value? if I draw 53% here, I ended up with like, what, 21%? But if I draw 53 here, I ended up with like 3%. Or no, it was 8%, wasn't it? So if your p-value is small, what does that tell you about your z-score? If your p-value is small, your z-score is large. Does that make sense, Sage? You get it? Awesome. If your p-value is small, your z-score is large. If your z-score is large, your SD must have been small. Okay? Lot going on there, and that's the whole backside of this worksheet. That's what it's about. If your SD is small, that's going to create bigger z-scores. If your z-scores are big, that's going to create smaller p-values. Okay. 31. If two surveys each found that 53%, oh, we did that one, 32. Which sample is farther from the null hypothesis? 55% support or 56% support? 56. Okay, so which one is going to have a larger z-score? 55 or 56? 56. Which one is going to have a larger p-value? 55. The farther away you are from the null hypothesis, the smaller your p-value is going to be. So if I draw this curve, remember p-value is this area. So if we move to the right, my z-score will go up, but my p-value will go down. Okay. 33. Which would give you a larger standardized statistic? Which is the z-score? A sample of 30 people with 57% support, or a sample of 30 people with 58% support? 58. How come? Sample size is the same, so a higher percentage is going to put us farther to the right, which means we have a higher z-score. Does everybody understand that? Okay. If some of these questions are super easy, that's good news. Okay. Like if you look at it and you say, oh, that's obvious. That's really, really good news. 34. Which would give a larger standardized statistic? A sample of 30 people with 57% support, or a sample of 100 people with 57% support? Well, let's try it. Let's run it through the app. So we're going to do 100, and my test value is 57. Okay. In that case, the p-value is 10%. Right? What was the next one? 30. So we'll run a test with 30, and we'll test the exact same thing, and my p-value is bigger with 30. So which one has a bigger z-score, 30 people or 100 people? 100. Okay, let me draw both of those, just so we make sure you understand it. So this is 30, and this is 100. Okay? This is 57%, and that gave me 27% as a p-value. And over here, 57 gave me 10%. So which of those two has a bigger z-score? That would be the one that is farther to the right. Which one is farther to the right? The 100. Okay? Okay. Gavin, I'm proud of you. Nice work. All those things I say about you, not true. Well, I'm not taking it back. I'm just acknowledging that they're not true. All right. 35. Which would give a larger p-value? 30 people with 57% support or 100 people with 57% support? Larger p-value, we just did that. It's going to be the 30. Okay, everybody good there? Which would give a larger p-value? A sample of 30 people with 57% support or a sample of 30 people with 58% support? 57 is going to give a larger p-value because it's farther to the left. Okay, we good? Awesome. Do you want to retry this one or are you ready? You didn't get to it at all? How many of you have this done? Okay, I'll give you a minute. Get to work. Okay. A member of a golf course country club claims to be better than an average golfer in the club. The average handicap among members is 78. One thing you need to remember is, what is a better score than 78? 77 or anything lower than that. This is golf where points are bad. Okay. All right. Could we use this to simulate the situation? Is there any way to use this app to simulate the golf scores? So we would need number of heads, right? And in addition to that, we would also need a standard deviation. So we would have to know the average golfer was 78 and the standard deviation of all members was 4. If we had that information, we could do a simulation, but this app won't work. This app only works for proportion, which is why it's called the one proportion app. If we wanted to do a golf score, we would need a different app that had different capabilities. So no simulation can be done for these set of problems. All right. What would the null hypothesis be? H naught is pi is equal to 78. That was the average. And then HA, pi is less than 78. If you have that mixed up, your answers are all going to be wrong. They're all going to be backwards, right? Well, maybe worse. Okay. 39 is an interesting question. Over the last couple of months, if our particular member has a score of 79, do we have enough to reject the null hypothesis? Yes. Why yes? It's higher than 78. So if that is our hypothesis, when I draw that sample curve, which I can't do, right? I can't use one proportion to do this. But the middle is 78, and I'm going to shade that direction. So do I know, or sorry, can I calculate the p-value? No, but I do know something about the p-value. What do I know about it? It's quite big. In fact, it's bigger than 50%. Does that make sense to everybody? So if I'm doing a one-tail test where I'm going to shade to the left and I end up on the right side of the graph, I don't need any more information. I can reject the null hypothesis right there. So this guy claims he was better than average, and his scores were worse than average. Is there any way that can prove that he's better than average? No, there's no way. So we could reject the null hypothesis right there without doing any calculations. All right. Which one would be more likely to reject the null hypothesis? 10 rounds with an average score of 72 or 25 rounds with an average score of 72? 25. When you have a larger sample size, it's easier to reject the null hypothesis. Does everybody get that? Okay. 41. Which is more likely to accept the null? A score of 76 or a score of 75? Assuming they have the same number of samples. 76, because it's closer to 78. 76 is closer to 78. How are we doing? Doing well? Okay. 42. Which would give a standardized statistic that is farther from the mean? 30 rounds with a 73 or 30 rounds with a 72? A 72, because it's farther from 78. Now notice, I did not say a larger z-score, because you run into negative numbers. Right? -2 is, I guess, theoretically larger than -3. So I said farther from the mean, right? So when I said you have a bigger standardized statistic, we usually mean distance from 0, right? We would consider -3 to be bigger than -2 because it's farther away. But you have to be careful how you say that. So I said farther from the mean. 43. What would give a z-score that is farther from the mean? 30 rounds 73 or 100 rounds 73? 100. 100 would be farther from the mean because it's farther to the left. Which would give a standardized statistic that is farther from the mean? 50 rounds 71 or 50 rounds 70? 70. Farther from the mean. Which would give a smaller p-value? 25 rounds 71 or 25 rounds 70? Well, how does your p-value become smaller? The farther away you are. So which one is farther away, 70 or 71? 70. Which would give a smaller p-value, 25 71 or 50 rounds 71? 50. Okay, that's it.